Hi students, welcome to another video of Smartly Learn. In this video too, we will continue to see about chain rule of differentiation. In the previous few videos, we have been explicitly seeing how to introduce a third variable and implement chain rule for differentiation. From this video onwards, I'm not going to explicitly highlight the third variable. However, I'm going to teach you to slowly make yourselves do chain rule like a simple mental calculation. This is particularly important because chain rule becomes a basic step for higher types of differentiation techniques. In even simple UVs and U by V methods you have done so far, chain rule will slowly become a part of the norm. So it becomes important for us to understand how to do simple chain rules by doing mental calculations. So let's start with simple examples wherein I'm going to do a chain rule without showing the third variable explicitly. Let us take the input function as y is equal to 4 secant squared x. So in order to differentiate y, we know 4 is going to be outside the differentiation. So it is 4 into d by dx of secant squared x. We know that a power like secant squared cannot be directly differentiated. So how do we usually do a chain rule? I treat the secant x as a variable t. So this looks like the format t square. So what is the differentiation of t square? It is 2t. So now let's see 4 into secant squared x part. I'm going to do this as 2 secant x. Then I have to differentiate the secant x with respect to x. This is equivalent to the step dt by dx in your chain rule. So what is differentiation of secant x? Secant x differentiation is secant x tan x. Now I can multiply the entire answer. I'm going to show this as 4 2s are 8. Secant x into secant x is secant squared x tan x. I'm just going to show this example parallelly using the concept of chain rule. So you see how the mental calculation was done. So I'm treating this as 4t square. So t square's differentiation is 2t. So this became 8t. Then I had to do a dt by dx, which in this case was a differentiation of secant x. So it became 8 secant x. D by dx of secant x is secant x tan x. So that is what I have shown here as a calculation. However, I did not bring in the variable explicitly to show you. So in the next example also, I'm going to do the same process of chain rule, but without highlighting the usage of this variable. So let us take another input function y is equal to cos 4x. Now let us do the chain rule. I know the 4x is going to be treated as a variable. So differentiation of y is going to be first a differentiation of cos x, which is going to be minus, I'm going to treat this as a t. So this is minus sine x, then a d by dx of 4x. So I'm going to do a d by dx of 4x, which is 4. So minus sine 4x into 4. That is my answer. So it is minus 4 sine 4x. So how you have applied the chain rule, but this time without showing any calculation. So I'm trying to reduce the steps of chain rule so that it becomes easier in the bigger problems. Let's try to do one more example. Y is equal to 1 plus cos x the whole squared. Now look at this. 1 plus cos x, I'm going to treat this as t. So y dash becomes a differentiation of t square, which is 2t. So my t is 1 plus cos x. Then a d by dx of 1 plus cos x. For now, I'm showing the differentiation of the t. Slowly, that also will be converted as a mental calculation. So this is 2 into 1 plus cos x, d by dx of 1 plus cos x. D by dx of 1 is 0. Cos x is minus sin x. So now look at my answer. I'm going to multiply and write this as minus 2 sin x, 1 plus cos x. So in the next video also, I'll continue to do chain rule so that you can understand how the chain rule is slowly going to be made like a mental calculation. Please extend your support to me by subscribing to my channel Smartly Learn. You can also reach out to me through my website www.smartlylearn.in for more practice worksheets. Thank you. See you in the next video. Bye.